Hey everybody. So this is a super cool library, but it's super new and there's not like any documentation on it whatsoever, even from the SmolAgents team. So I figured I'd kill a few birds with one stone here and go over this, review exactly what SmolAgents is, how it works, and then give you some kind of like documentation and like a resource guide that you can use as you go through SmolAgents. So starting off with exactly what this is, it's exactly as you would think, right? It's an agent platform, and then they bill it for its simplicity. Is kind of their goal within it. It's very easy to install. It's just pip installing the package, and then you define what you want the agents to do. Keeping in line with like everything being open source, it utilizes DuckDuckGo for its search tool as opposed to Google. So you get a free search tool, which is really cool. And then it can utilize other tools in a toolbox. And then so it's kind of like if you're familiar with agent platforms, it's very straightforward in how that works overall, right? It's a toolbox, and then there's tools in the toolbox, and you can even define custom tools. And then there's predefined tools and custom tools. And other than that, there's not really a lot more to it. You can call LLM models within the framework. It will default call LLM models. It will default call BERT if you distill BERT. If you need to make LLM calls and you don't actually specify the model, I tested that out, so you have that there. But other than that, it's very straightforward. And then again, there's not a lot of documentation on it, so or any so far. So let's like go into the agents itself, right? So first thing I do is based off of what they provide within the GitHub, I install and I like set up my SmolAgents, and then so install it and I run it. And I run it with a simple query, which is how many seconds would it take for a leopard at full speed to run across the Pont des Arts in France, in Paris? And then so, first of all, like I would highlight this and I would point this out if it was anyone else. So I'll point this out in this instance. When you pip install the SmolAgents package, it's small, but like with this code here, but like it's installing a lot of packages. Like at the end of this, like, and it goes through, and then like I mean, all of this execution takes like this is standard, right? Well, I mean, it's like you see all of these installed packages at the end, like all of this, right? Like right here. And then so it's a lot of packages that it installs, and then most of them are very straightforward and expected, right? Like radio, fast API, light LLM is a big package in and of itself. E2B code interpreter, safe HTTPX sounds pretty good. I know I need the DuckDuckGo search. So like HTTPX. So I know I need some of these and a lot of these, but like it's just, I mean, it's a lot that it's doing and installing. And again, if it was like if it was a small entity, like I'd highlight this and be like I would not trust this overall, right? Because it's doing so much with the package installs. But again, it's Hugging Face, and they're like reason why they put it like they lay it out very specifically in the GitHub that they want this to be compact and lightweight. Well, mission accomplished there, right? And so there's a trade-off. Like if it's compact and lightweight on the front end, it still has to install packages on the back end, and so it does. It installs quite a bit. Just highlighting that. So let's move on from that though, and let's go through and let's actually run it. Right. So we have our query that we run, and then let's see how this model performs. And then so it performs and it operates this query exactly as you would expect an AI agent to. So it's going to break this query down, this larger query into smaller subqueries. And then so the first thing that it needs to do, then the first question it asks itself is, how many seconds would it take for a leopard to run at full speed? So it asks the full question, and then it needs to know the length of the Pont des Arts in Paris. And then so it does this, right? So it does a DuckDuckGo search via Wikipedia. and it gets a length which is 509 feet, or 155 meters, and then it goes through, and then it gets the whole Wikipedia article, and then from there it cross-references that with the top speed of a leopard, and then the first result that it gets back is 56 to 60 kilometers, which is about 35 to 37 miles per hour as the top speed of the leopard. And then it gets other data about the leopard that is insignificant to its query. And then its next step is to put this into code to calculate it out, right? So it calculates out that the top speed of a leopard is 58 kilometers per hour. So it takes essentially like the average between 56 and 60. And then it converts that to meters per second, so 3.6 meters per second, and then it calculates the length of the Pont des Arts as 155 meters, and then so it outputs the answer as 9.62 as the response. So its final answer is 9.62. So pretty cool there how it works overall, right? And then so it works very straightforward and exactly how an agent would operate. And then so if you have like very simplistic tasks like this, you could run your agent all day long. Let's go with a more complex task, right? So in this instance, for our more complex task, let's say we want to know the average building price of a house in San Francisco. We'll do that as our query, right? And then so again, it's got to go through all this massive package installs, and then we go through there, and then it does the query. And then so first thing it needs to do is break this down into a few different subcategories, right? So it needs to know average cost of cement in San Francisco, average cost of steel, average cost of bricks, and then it searches those, right? So that's what it's going to use for its building cost materials. It's going to get results back for all of these, and it's just utilizing, and it's going to average out the results that it gets from these different web pages, and from these different web pages, it's going to get different results, right? And it doesn't up front, and we run into the first problem in highlighting this when it comes to agents, right? Like this agent is going to treat all of these results the same, whether it's from 2024, 2023, how good the website is comparative to each other. You can build out and you can make your agent more complex, but then you're building out and making your agent more complex by doing that. In this instance, we're not doing that, right? So it's just going to average out all of these, treat all of these websites the same. A website is a website, and that's all it is. It gives us data, and then so it's going to average out the costs, right? So for cement, it's $3 per square foot for the minimum cost, and our maximum cost will be $4. So it's going to average it out to $3.50. And our steel costs, same thing, right? 40 cents is the minimum that it got, $1.25 is the maximum, and then so it's going to average it out. Same thing with bricks. It found that the max was 75, the minimum is 55, and then so it's going to average it all out. It's going to take a house of 2,000 square feet. It's going to average out our labor costs and assume that our labor costs are based off of our material costs at 2.25x material costs. And then so up front and highlighting this is a bad calculation for labor costs, right? Like it's going to work in this instance and for what it's utilizing it for in these calculations, just because it's how the math works out. So if you just look at the end result of what it calculates here, it's going to calculate 48,000 for the labor costs compared to 21,750 for the material costs, which is good, right? But you would want a better labor calculation than just simply flat out 2.25x your labor costs, right? It just seems to me you would want that to be more complicated, but that's what it's doing in this instance. And then so if you don't check it and you just let it run, that's what's going to happen, right? And then that's the next big thing that I want to highlight within this is that so these agents, they're going to run and without supervision, right? Is kind of the big thing that is missing within here. There's SmolAgents, which is awesome and kind of where we're at, but where we're at, there's not a small supervisor within this, right? And that's kind of to me, the missing element that is making this more like not more than novelty for my approaches when it comes to actual real world applications, right? But then, so let's go into, like, before we dive further into that, let's dive into like an actual real world use case, right? Like, I'll demonstrate what it will do. So let's have it make an API call, and then in this instance, I'm going to have it make an API call to Catfax, just because I don't want to deal with API keys and all of that. I just want something simple, and then I want it to visualize the data, and then in this instance, I'm going to do something really cool, right? Because I did this before, and I did this once. So I'm going to have it visualize the data, but then I'm going to have it go through and logic check itself. So it's going to go through and it's going to create a report based off of this data. It's going to pull the data, summarize it, and then pull a report, and it's going to ask itself, like, okay, is this summary and is this visualization, like, would a human actually find this useful? If no, it's going to do it again, and it's going to try it again. And then so we run it. No model was supplied, so it defaults again to DistillBert, as I mentioned at the top. If you don't, in this instance, because it needs an LLM model, so I didn't define it. I wanted to see what would happen. It defaults to DistillBert, which is fine. And then so it fetches the fact, it analyzes it, it generates the data for our report, and then it creates a summary, generates the final report, evaluates the usefulness of the report, finds that the report isn't useful, and then regenerates the report. And then so here's our final report that it does. And then so it just pulled a cat fact, right? It's just a random cat fact. And then so, which is that cats have been domesticated for half as long as dogs have been. It found that this tends to be, it found like very highly, which is a negative sentiment within this. And then it plots the mean, the max, and the minimum with regards towards the sentiment analysis that it found within this particular. It's basing this graph off of sentiment analysis here, and then it gives you its charted analysis. And then so that's kind of a full breakdown as to what all this does, right? So bringing you from SmolAgents does, bringing you from the most simplistic example to more complex use cases and bringing in LLM models. And then if you want to, it would be easy to modify this code, bring in your own LLM model, bring in like GPT-03 as a supervisor if you want to within this, right? And that's where it could get more complex, and you could add real complexity to this, and then it becomes a real agent framework that's really robust in that instance that you're paying a lot of money for, but it would be there for you and very useful in that instance, right? But so highlighting overall what tools are in the toolbox. So again, this entire framework, bringing it back up high level, this entire framework is essentially just giving agents in this instance, or machine learning agents or algorithms in this instance, access to tools within a toolbox. And then so what exact tools do they have? The first tool that they have is local execution tools, which allows them to just run Python code snippets, and then they're like pre-built snippets for like mathematical calculations, data analysis, file manipulations, and data transformations. Like very straightforward, right? Like they're like the adjustable wrench, right? Like your go-to tool. And then API integration tools. So like they know how to make API calls, and they're very well trained within that. And they have an agent that specifically calls, that's a specific call agent for API integration tools. So this would be like your socket wrench. Managed agents that can call on other specialized agents to complete subtasks. These agents, they can be configured. So agents that can call agents is basically it, right? And it's like your WD-40 within the toolbox. Like whatever you need to do, like if you need, like you can daisy chain agents together to perform a lot of tasks, right? Like, and then it's while this task is very complicated and there's no way that a single agent can do it, well, 3 agents daisy chained together could do it. And then you can pretty much do a lot of things by doing that, just by daisy chaining multiple agents together. And then moving on, you have multimedia tools. Very straightforward, right? Like if you have to deal with images or audio, you have an agent that's very specifically trained for images and or audio. And then all of these are individualized agents again, right? So they're individual tools. Like I reference them as different tools within the toolbox, and that's exactly how they are, right? So then if you need to then have more specialized Python libraries, so you need to access like NLTK or Matplotlib, anything along those lines, you have a specific agent that's trained for more advanced coding, right? So you have your basic agent for coding, and then your more advanced agent, and an agent that decides what needs to be done within that. And then you have custom tools. You can create your own tool and define how that works, and then you just have to define the tool, give it a name, a description, and how it operates, the logic of it. And then you have your advanced planning tools, which are like logic-based tools, right? So this is what is coordinating all of this, and then if you need to actually do plans, and then so generate tasks on the fly, generate plans on the fly, etc. That's what this tool is doing. And then data visualizations, anything that needs to do that for chart visualizations, etc. And then your final answer tool. Taking all of the data that you're getting in and like ingesting all of this huge amounts of data that it often gets, as we saw with those queries, right? Like those queries are taking in a lot of data back from like the Wikipedia search, for example, and then so it's cross-referencing, and then it's just, is this your final answer? And then it's just querying itself, and then that's very powerful, especially when it comes to these agent models, right? Just adding an additional loop on itself. Very straightforward. And then remote execution tools basically just allow it to execute code within a sandbox environment so that it doesn't go off the rails and actually mess up code in a real world environment. And then so it's very straightforward as to how this operates. And then the last one is last here, this tool integration workflow is just there for you if you want to, again, create your custom tools. You define the tool, you add it to the toolbox, and then you define how the agent utilizes the tool. Very straightforward, right? But so all of that combined and all of this combined is your agent toolbox. And then so the toolbox is again like the entire essence of this. And then each individual tool is combined and can be an individual agent, or it can be a framework. It doesn't have to be a probabilistic agent. It could be a very linear function, and only a linear function, and that could be a tool, right? So you have linear and probabilistic tools, just like you would when it comes to any other machine learning task, but they break down to tools in this instance for the toolbox, and then the machine or the agent in this instance is just utilizing the tools that you give it, and then it goes through and performs those tasks. And then so again, like the major drawback to this is that this works wonderfully as long as the agent is executing every single step within this accurately. But if there's one step within this that's wrong or that you don't like, it's going to throw this all off. And then so going back, the one thing I don't like about its calculations that it's doing within this is this total labor cost, right? I hate this calculation that it's doing within this. It's doing it every single time in all of these outputs, and we're getting this unless I tell the model to not do this, it's going to do this 100 times, 1,000 times without supervision, right? And that's the major drawback to this. So it'd be a waste of tokens if I decide I flat out don't want this data, or it's not useful because of that kind of very invalid calculation based off of that, right? And then so really highlighting that as the drawback within this. That's kind of where we're at, right? You 1,000,000% should never run this without human supervision. Absolutely have human supervision checking over this, even if it's the most basic agents that you're running. But you do have agents, and you can eliminate humans from a lot of the equation within this to simplify it. So if you like this type of content, please like and subscribe. Thank you very much.